So let's get this question here, which is on connected rate of changes, which application of differentiation. In the diagram, the angle theta is subtended by the minor arc length here. AB is a fixed radius of 5 and is increasing at the constant of alpha. Oh, okay, great. So d theta dt, just imagine this is increasing at alpha radian per second. So find the rates of change of area of minor arc ACB. So we want to find area of DADE ACB at the instant when the area of a triangle OAB is rates of change of the area. Rate of the typo here shouldn't be R, just one rate. Get it? So there are two rates involved, okay, because as you increase if you increase I think the area OAB here, we have two values which we need to find. So later we find. So let area of minor segment ACB DA. Okay, so this case here we want to find DA dt. Similarly, just use DA times DA sub t. It doesn't take long for you to know that this should be d theta and this is d theta. So you need to find ACB in terms of theta. You need to find find A in terms of theta. There you go. So what you need to do next is essentially just find A in terms of theta. So it shouldn't be a problem there. It's just a geometrical problem. So I'm gonna just take A is just area of this is A area of OAB minus area of triangle OAB. Okay, so A will just be actually just half R square theta. So minus of area is half AB sine theta. Okay, so just is half AB sine C. Maybe I just put this half AB. So half C. So area here we half pi square theta minus half 5 times 5 sine theta. There you go. So got this will be 25 over 2 theta minus 25 over 2 sine theta. Great. So there you go. You use DAD theta. Shouldn't be a problem. DAD theta will be 25 over 2 because we need DAD theta here. Then minus of 25 over 2 cosine theta. Great. This is our value. So DADT, so this DADT here would then be this value. Okay, so I'm gonna just put this down. So substitute this in to this. So this case here we have DADT is DADT, which is 25 over 2 minus 25 over the A multiply d theta dt is alpha. Okay, so there you go, done. It could simplify is 25 over 2 1 minus. So we found this generic rate of change of area, but the problem now is the area of minor segment when the area of OAB is 7.5. So when area of OAB, when area of triangle OAB is 7.5 cm square centimeters, what we get is half is this over here. We just use half AB sine cm. So we half 5 times 5 sine theta 7.5. So there you go. There are two values here. So 525, 7.5 times 2 divided by 25, that will be 0.5 here. They do not want the exact value. 5. Oh, they want the rates of change of it. So in terms of theta, okay, great. Sine theta. So this case is pretty okay. This tells you that theta is in Q1 and Q2 because there are two rates here which we need to find. So what I'm going to do is actually just draw the triangle. not an issue. Theta, and then we have got opposite is 3, adjacent is 5. So this will be 3, 4, this is 4. Okay. So cosine theta, because in our formula here, there's a cosine theta here. Cosine theta in quadrant 1 would be 4 over 5. Quadrant 2 is a negative, so or negative 4 over 5. Then we're just going to key in. So hence, dA dt will be 25 over 2, 1 minus 4 over 5 alpha, or 2 over 5 to 1 minus 4 over 5 alpha. Then just key in calculator. So this will be 5 over 2 alpha